another letter. Let's see what this one says. Dear Mr. Hawk, these Desmos activities are really groovy, as I think you people say. You people? What's that supposed to mean? But I just wish there was an easier way to find the vertex. I know you showed us vertex form, but what about standard form? Can the quadratic formula help us? Also, your dog is so cute. Do you have any other pictures you can share? Sincerely, Curious in Crown Heights. She is very cute. Thank you so much for writing. I love it when people write in. Yes, it just so happens I'm going to be able to show you another way to find the vertex today. Stick around. First, let me tell you where we've been, and then let me tell you where we're going today. A few weeks ago, we started learning about quadratic functions, and we would take one like this, and first we could sketch it. And then let's say we wanted to find the point on the vertex. Well, to do that, we would factor the equation. We would then find the values of x that made y 0 to find the zeros. We found the line of symmetry that was halfway between those zeros by finding the average or the mean. And then we would plug in that value of x to find the y value of the vertex, which in this case ended up being negative 48. Well, today we're going to build on the work we did yesterday with the quadratic formula to be able to quickly find the vertex of a quadratic function. To get there, you'll find a pattern in Desmos, you'll form a conjecture, you'll see an example, you'll practice, and then if there's time, you'll play some fun Desmos games. Let's get into it. Your directions are here. Answer the questions on screens 1 through 6. This is screen 2. This asks you to move the purple line to show the location of the line of symmetry, and then choose the equation that describes the line of symmetry. You will then move the purple line to find this line of symmetry. The zeros of this function are listed here. Once you've found the line of symmetry, you're going to enter x equals whatever it is, and maybe start to notice a pattern between what's up here and what's down here. This screen is a little different. You don't have a purple line to move, but you can definitely see the line of symmetry here. What I want you to pay attention to is this. If this is one of the zeros and that's the other zero, you want to know what the line of symmetry is. How could you have found the line of symmetry without seeing this graph just by looking at these zeros? Finally, you're going to look for a pattern here. Here, all of your answers have been populated, and you want to be able to find the line of symmetry of this function, ax squared plus bx plus c, if you don't know what a, b, and c are. And here's a hint. The solutions, or the zeros, are written here. You're going to enter your answer right here. And then on this last screen, you're going to share your overall thinking. This is you coming up with a conjecture of how we can use the quadratic formula or information from the quadratic formula to quickly find the line of symmetry of a parabola. This is going to be key in quickly finding the location of the vertex of the parabola, which is on the line of symmetry. Your teacher's going to send you into Desmos now, and then your teacher's going to call on some people to explain their thinking, lead a quick discussion about their thinking, and then bring it back here. I hope you had a great discussion. I hope you had some fun playing around in Desmos. I just wanted to stamp for you the key idea behind today's lesson, which is that the line of symmetry of quadratic function in the form ax squared plus bx plus c, standard form, is x equals negative b over 2a. This is also the x-coordinate of the vertex. Now you might be wondering, how do we find the y-coordinate of the vertex? And the answer is it's the same way we found it before. Once we know the x-coordinate, we can substitute the x-coordinate into the function to get the y-coordinate of the vertex. Now I'm going to very briefly walk you through an example, and it's the first example that you're going to see when you go back into Desmos to try to find the coordinates of the vertex. Okay, so if I want to find the vertex of this particular function, well, I need to identify my a, my b, and just for fun, my c. A is negative 3, b is negative 24, c is 4. I could find the zeros by plugging those into the quadratic formula. X equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. I'm going to do you a favor and not sing it to you. But if I want to find the location of the vertex, this part right here, negative b over 2a, is all I really need to know. So the vertex is at x equals negative b. Well, if b is negative 24, then it's positive 24, over 2a. 2 times negative 3 is negative 6, which gives me negative 4. When I simplify this, 24 divided by 6 is 4, and it's going to be negative. So now I know the x-coordinate of my vertex. How am I going to find the y-coordinate of my vertex? Think about it. That's right. I'm just going to substitute negative 4 where I see x in the original equation. So I'm going to rewrite my original equation as y equals negative 3. Instead of x squared, I'm going to write negative 4 squared minus 24 times negative 4 plus 4. When I simplify that, I get negative 3. Negative 4 squared is 16 times 16. Minus 24 times negative 4 is the same as plus that times that, which is 96, plus 4. Negative 3 times 16 is negative 48, plus 96, plus 4. I could have combined those if I wanted, but I didn't feel like it. And now I have those two together is 48 plus 4. It's going to be 52. So the coordinates of the vertex is at negative 4, comma 52. I would then just spot check by looking at the graph itself and see, does it look like the vertex is at negative 4, comma 52? And in this case, it does. So once again, I use the first part of the quadratic formula, negative b over 2a, to find the x-coordinate of the vertex. I substituted that into the original equation for x in order to find the y-coordinate of the vertex. And then I checked it against the graph to make sure that I could be right. You're going to be following these steps a lot today to practice. You're also going to be practicing finding the actual solutions to the equation using the whole quadratic formula like we practiced yesterday. And then there are some fun games for you to play around with that are going to help you to build your concept of how parabolas work. Have a great time, learn lots of math, and I'll see you soon. Bye.